Okay. Waste can include different types. One of the first types are agricultural waste, that including crop residues and manures. Then you have industrial waste, that's the major one. That's the major one. Industrial waste, other than mining and mineral production, amount up to 400 million metric tons per year in the United States. So that's the major source of the waste. Then you have municipal solid waste, like the garbage we produce in the houses, offices, cities, account for a small, tiny percentage of the total waste. As I said, the main thing is the industrial waste. The waste stream is everything we throw away. The waste stream is a term that describes the steady flow of a varied waste that we all produce, from domestic garbage and yard waste to industrial, commercial, and construction refuse. Many of the materials in our waste stream would be valuable resources if they were not mixed with the others, and they can be easily recycled. And sometimes the recycling is a big issue because you have a lot of other waste mixed with some valuable resources, such as aluminum cans, for example. It's sometimes very hard because they are mixed with other toxic waste. Unfortunately, our collecting and dumping processes mix and crush everything together, making separation inexpensive and sometimes impossible to do. And that's what I said. Sometimes we have very valuable resources from this waste, but it's very hard to recover or to recycle. What is the waste stream? Well, waste stream contains all the waste coming from organic materials, such as yard and garden waste, food wastes, and sewage sludge. Junk car, worn out furniture and consumer products, newspapers, magazines, and so on. All those are type of waste is dumped into. It ends up in landfill, but if we can't catch it, it ends up in the ocean. So most of the waste is not accounted for. It ends up in the oceans. Waste disposal method. Where do our waste go now? We'll see in this in this slide, this PowerPoint slides, you will see that most of the waste is manageable through the landfills, and some waste we cannot really do anything about it. We have to put a special. That's not in the slide, but that's like nuclear waste. What you do with the nuclear waste, you can't dump it anywhere. Even you can't dump it, you can't burn it, you can't do nothing. So nuclear waste end up in special containers, most of the time made of lead, and then dumped, buried into the ground. And that's what sometimes is very scary. That's if you get earthquakes, those containers can be cracked, and some of this nuclear waste can leak into the tower, into the ground level, tower layers, or dumped inside, leaked into the oceans. So, open dumping releases trash to air and tower. Open unregulated dumps are still predominant methods of waste disposal in most developing countries. Most developed countries forbid open dumping, at the least in the urban areas. But as I said, that's what we have seen at the Clarkston Campus stream there. We have a lot non-open source of the dumping of a lot of waste, a lot of trash, and mostly tires. All tires are dumped there, and empty oil cars, empty oil for the cars, but there is some residue at the bottom of those oils still there. Most developed countries forbid open dumping, as I said, but always you have illegal dumping, still a problem. But I think at Decatur campus, I think they now have cameras. I think at my time, long time, 20-something years ago, they did not have cameras. We did not know who is dumping what. We have a lot of stuff dumped into old newspapers, lot of tires, lot of oil, car oil, empty bottle, not empty, some of it is still oil inside, leftover oil inside, dumped inside the stream. So we don't know who had dumped this. And the major problem is our botanical garden there, and somebody had visited there. We had worked and volunteered our classes as extra credit. We went to them. I went to them several times to the botanical to help the people there. So this stream is the main tap water source for the botanical garden and for the animal there. We have a lot of animals back there. So we have deers, we have raccoons, squirrels. We have a lot of even snakes over there. Yeah, sometimes the snakes are going into the classrooms. We have some classrooms trailered close to the botanical garden. So those animals will be affected with all the waste dumped with no regulation. Nobody knows who had dumping, but we know what they are dumping, but we don't know the source of the manufacturer or the person who had dumped those things. Much of this trash washes into sewer and then into the ocean. That's what I said. But we have a very small, tiny stream at Decatur campus, and then end up not in the ocean yet, but it end up in the big lakes or ponds, and then from there to rivers, and most of the rivers end up in the ocean. Much of illegally dumped garbage often include toxic chemicals which show up in the ground tap water. So that's what I said. In our case at Decatur campus, we had a lot of empty what they call empty car oils bottles. Every year, some 25,000 metric ton, about 55 million pounds of packaging, including 500,000 bottles, cans, and plastic containers, are dumped at the sea. Well, we saw even at Decatur campus stream a lot of empty plastic bottles for tap water, a lot of empty ones, and that's a plastic there. And the problem of this plastic is non-degradable, means it will stay with you for thousands and millions of years to come. It's not biodegradable, means it does not really decompose by itself naturally. No, so you have to work on it to get rid of it as a waste. Even in remote regions, beaches are littered with non-degradable flotsams and jetsams. That's what I said. Those are non-degradable, means they will stay with you millions of years. They will not go away. And if they are dumped, those in ocean, those cause a lot of problems to marine life. So some of especially old nets of the ships, old nets dumped in the ocean, those can cause a lot of suffocation, a lot of trapping of marine life there in the oceans. About 150,000 tons, about 330 million pounds of fishing gear. That's what I said. Or nets, or nets. Those fishing nets, they end up in the ocean, and they are spread out over 1,000 kilometers, 660 miles. Of the nets are lost or discarded at the sea each year. So each year you get a lot of uh, all fish nets and all fishing gears are dumped inside the ocean. Until recently, many cities in the United States dump municipal refuse, industrial waste, sewage, and sewage sludge into the ocean. I think now it's not allowed to do that. Federal legislation now prohibits this dumping. The Great Pacific Garbage Patch. The Great Pacific Garbage Patch, those mostly, if you look, this is mostly plastics, believe it or not. Most of those plastic we buy from whatever you go to buy, and you get your food from stores in a plastic bag. Those bags end up in the ocean. Empty plastic bottle, they end up in the ocean. So they were found in 1979 by a sailing captain. His name was Charles Moore. Is the best known of these plastic debris fields. In all world ocean, vast circulation currents known as gyres are driven by Earth rotation. Those currents collect floating plastic debris, much of it tiny fragments in regions thousands of kilometers wide. So you can see all those waste dumped inside the ocean. It will not stay in one spot. Not even the country or the continent are producing this waste or this, but it can go through all the whole globe, from one continent to the other continent. So depending on the circulation of the way of the ocean's waves. North Pacific gyre has captured at least 100 million tons of plastics. Landfill receive half of our waste. Back to the ocean, I want to just let you know, not only this plastic will just suffocate fish, but we have other type of marine lives. This is very crucial for the balance, the eco balance inside the ocean. Did you see the coral, how they look like? That's very essential. And this, if there's a lot of plastic, those bags come in the top of those corals, you suffocate the corals. They cannot get dissolved oxygen. They are like fish. They are breathing in dissolved oxygen. So they breathe oxygen, but in a dissolved way. So when you get all this lot of bags, plastic waste bags, dumped on those corals, so those corals will die out. And that's very crucial for the eco balance, because a lot of parasites, a lot of small, tiny fishes or bacteria can sit on them, can take them as a hosting residence. Then other fishes can come and eat on those small, tiny parasites or small, tiny fishes living inside those holes in the coral kingdom. So that's another way to look at it. And you can Google YouTube. You can see this is a big problem with those plastics, especially plastic bags and bottles dumped inside the ocean. Landfills receive half of our waste, and that's really true. That's really true. Landfills receive 50% of all U.S. municipal solid waste. The rest 50 is what will be combusted, will be burned into the air. Now that's another problem, because when you burn the waste, you might have some of this waste, some toxic waste, and you produce toxic gases dumped inside what? Inside the air, which will affect the air quality and can cause a lot of cancer, lung cancer, because you have a lot of gases are dumped from this combustion, burning this waste. A modern sanitary landfill is designed to contain waste. You can see they are really, you can see the waste is, those landfill is, then they put a lot of plastic on them, so they, to protect the ground, so any waste liquid is not seeping into the ground and affecting the tap water quality there. So a modern sanitary landfill is designed to contain waste. Refuse is compacted and covered daily with a layer of dirt to decrease the smell and discourage bugs and rats. To reduce leaks, landfill use impermeable lining. They use a sort of plastic cover. You can see it's not allowing any liquid going through, because some of the waste we dump, not only solid, but some of the waste it has it comes in a liquid form and can seep into the soil, which affecting the tap water quality. Methane and landfill. Well, part of it is of all this waste we dump in those landfill is methane, which is produced which is produced inside those waste, and methane is considered the major component of natural gas. Methane is natural gas, major components. Landfills are the single largest anthropogenic source of methane in the United States. Globally, landfills are estimated to produce more than 700 million metric tons of methane annually. Now, about half of all landfill gas in the United States is either flared, burned out, combusted, that's another problem, on site, or is collected and used as a fuel for electrical generation, which is the best choice to control this waste. Burning is always not a good choice, but we don't have other choice. We have to burn this. We cannot keep just accumulating those waste for a long time. We often export waste to countries equipped with for countries of developing countries to handle it. Well, most of the developing countries, they don't have the technology, the sophisticated technologies to handle this waste, especially the nuclear waste. As I told you, this is very dangerous to just export this waste to the third world countries, or they call it developing countries. The problem is they have no technology, and if they have a leakage, the leakage of this inside the ocean, as I said, you cannot control the ocean waves. So you dump it in one side, it might appear thousands of miles the other side of the oceans. So not dump it whatever in Pacific, it end up in the Indian Ocean or in the North Pole area. So it's very hard to control the currents and the move of waves, and that's, I think, most of the developed countries, they have regulations, strict regulation, not to send waste to third world or they call it developing countries, that they have no technologies to handle those types of waste, especially the nuclear one. The nuclear waste is the worst. The nuclear waste is the worst by far. Most industrialized nation agreed to stop shipping hazardous and toxic waste to less developed countries in 1989. But practice still continues. But that's not at the level of the government. Those are special, sometimes, companies. They don't have resources, the funding for recycling or getting rid of this waste. Some companies will do that, but at the stage of governments, they don't do that. And most of the time, we have seen, as I have seen, some of the Chinese companies and South Korean companies, they are dumping a lot of waste. I told you, you can Google that, near the Indian Ocean, near Kenya, that area, Kenya, Somalia, that area. It's a lot of waste. And those are not governmental. Those are just private companies. They have no resources to deal with this waste. They can come illegally in the night and dump the whole thing. And then the next day, the fishermen or fisherwomen, they go and fish. They see a lot of fish near the area of Kenya, Somalia, that area, a lot. And they track They complained to United Nations. They tracked those fish through satellite. They found that Chinese companies, some, not all of them, but some Chinese and South Korean companies, they come illegally and dump some stuff. Not the governmental and the role of the governmental stage. They don't do that. But those are companies. They don't have the resources to handle this waste. They come in the area, nobody can see them in the night, and just dump it and run away. And they don't think that there is a satellite. They know which ship had entered what. Everything registered by the satellites, or movement in the ship, in the whole globe, in the whole Earth. Most of the old, obsolete, old ships are now dismantled and recycled in poor countries. This work is very dangerous because those old ships, I have seen them too. I have seen them. The old in the near Kenya area, so and the Somalia area. Most of those ships, they're old, and some of the manufacturing stuff inside those ships toxic. So that means those old ships, when dismantled, they leak all the stuff inside the ocean, killing a lot of, I would say, innocent, quote unquote, innocent fish. And that will affect even the people of that area, correct? So discarded electronics is another problem. Discarded electronics or e-waste is one of the greatest source of toxic material that's currently going to developing countries. So old computers, old computer screens, old electronics end up dumped inside the developing countries and end up in the developing countries, or they call it third world. They burn everything. And they will be wondering why, if you look in Kenya, Somalia, Uganda, all that area, Ethiopia, Eritrea, and that area, that's a lot of lung cancer. Because they dump everything is taken, because they take the money from the companies and they burn everything to the air. Burning to the air electronics will cause a lot of pollution to the air, and then people are inhaling this polluted air. Guess what? Then you end up with lung cancer spread out all over the countries there. Incineration produces, incineration means combustion. You are burning this waste with the high temperatures, produces energy from trash. Many cities use waste incinerators to burn municipal waste. Most incinerators do some degree of energy recovery using the heat derived from incinerated refuse to heat nearby buildings or to produce steam and generate electricity. As I said, this is no other way to go through this, but it will be in the future to just stop even burning any of this waste and come up with a very better ideas to get rid of the waste. Because every time you combust, you burn this waste, this waste end up in the air, correct? Because this waste is gas. Those gases, some of them might be highly toxic and end up affecting the population living nearby those plant waste plants. Refuse-derived fuel is what left after unburnable or recyclable materials are removed. There is a fuel will come out, okay? Mostly this fuel is gas, but if you have unburnable ones or recyclable materials, then there will be like soot, like sludges, like something is not burning, or partial combustion, then it'll end up as a soot. And as I told you, soot is one of the major tumor source for lung cancer. So soot because the small tiny particles dumped into the air, and you cannot see it's nano, their radius, those particles is in the nanometer. You cannot see it with your eyes. They end up inhaled, and they go inside the healthy cells, and then they punch through the healthy cell, causing them to mutate, and then you have tumors, then end up you having cancer, mostly lung cancer. Another approach called a mass burn, and burn as much as possible is to dump everything into giant furnace unsorted. Well, that is used, but as I said, in the future something has to be changing something, because we have to get out of this combustion, out of this waste burning. Incinerators can produce health risk, yes. If they are not well built and well managed, incinerator can produce large amount of ash. The ash is most probably is soot and hazardous airborne emissions. That's ash is the oxides, but the airborne emissions, that's the soot itself. Residue from a mass burn often contains a variety of toxic components, including dioxin and furanes, lead and cadmium in incinerator ash. And they did not mention the soot, but the soot will be there. Anytime you have in the solid waste organic compound and you combust this organic compound, you'll get CO2, H2O, and then if burning is not complete, combustion is not complete, you get a soot. These toxic materials are more concentrated in the fly ash, which can be penetrate deep into the lungs. Did I spoke about the lungs from the beginning? Yes. And everything with burning and combustion is end up inside the air, and then which causes the lung cancer. In one EPA study, all of the incinerators examined exceeded cadmium standards, and 80% exceeded lead standards. So that's a problem with burning. Every time we are burning, shrinking the waste stream. This is another way of not just dumping in the landfill and then burn everything, but we can shrink the waste stream. Compared to landfilling and incineration, recycling saves money, energy, and raw materials, landscape, and pollution. Recycling is, I think, by far now is the best choice we are doing. Recycling is the best choice. Is a reprocessing of discarded materials into new products. So we don't dump this stuff, but it's not, recycling is not 100%, but by far is the best healthy choice to manage this waste, rather than just dump it and then burn it. Sometimes the same products are remade. For example, old aluminum cans and glass bottles are usually melted and recast into new cans and bottles. Alternately, entirely new products can be made from old ones, correct? So the soda cans, they can remanufactured, and then you get new aluminum can out of this old discarded one. For instance, old tires can be shredded and turned into rubberized playground or road surfacing. That's just an example. As I said, recycling is the best choice. That's my opinion, and you will agree with me. Recycling is the best, so you can manage this waste dumped inside the ocean or dumped inside the landfill. Recycling saves raw materials. There have been some dramatic success in recycling in recent years. Nationally, the U.S. recycles or compost 1/3 of all municipal solid waste. Aluminum is probably the easiest and the most valuable material to recycle, yet only half of aluminum cans are recycled in the United States. So, and the half is dumped because they are crushed with the other waste inside the landfill. So, half of that, those are the ones are kept away from mixing itself with the other solid waste. Those are recovered. Americans still throw away nearly 350,000 metric tons of aluminum can each year, enough to make 3,800 Boeing jets 747. Wild fluctuations in commodity prices are also a challenge to developing a market for recyclables. Recycling saves money, energy, and space. As you can see, recycling, as I say, this is a very important feature of managing the waste and managing and controlling the waste. Curbside pickup of recyclable costs around $35 per ton, as opposed to $80 paid to dispose of them at an average metropolitan landfill. So you can see the difference. If you recycle, then your cost is $35 per ton. If you dump it in the landfill, that will cost you $80 per ton. $35 per ton if you recycle, and $80 if you don't recycle. Recycling lowers demand for raw resources. Recycling also reduces energy consumption and air pollution, and that's what I said. Dumping and burning every time, that's not good, because you polluted the air with some stuff. You don't know what's inside this waste of material, so you just burn it and then you hope for the best. But there's a lot of stuff will come into the air, which really affect the quality of the air and cause a lot of lung cancer. Anytime you see a country that has a lot of lung cancer patients, then you can see that the quality of air over there is not good, and there are too many pollution inside the air, and too many pollutants are sent to the air, mostly from burning landfill most of the time. Making new steel from old scrap offers up to 75% energy savings. Producing aluminum from scrap instead of bauxite or cuts energy uses by 95%. You know that aluminum is made from bauxite, which is aluminum oxide. Bauxite means aluminum oxide. That's really a mineral. So to get this aluminum from its minerals is most costly than to recycle old aluminum cans and old aluminum material. Composting recycles organic waste. Pressed for landfill space, many cities have banned yard waste from municipal garbage. You cannot put your shredded shredded trees, shredded leaves, anything, or old fertilizers. You cannot dump it inside your trash. You have to put it aside, so the county will come and take it aside as another type of trash. You should not mix those with the normal waste trash, which end up in landfill and which end up most of the time burned. Rather than bury this valuable organic material, they are turning it into a usable product through composting. So those are the ones are not mixed with the general waste. Those that you can reuse them for manufacturing a lot of other things, or you can just keep them and then let bacteria get rid of them just by them. So and then, or you can reuse them as I said. Composting is the biological degradation of organic matter under aerobic conditions. So there's some bacteria will feed it. The bacteria, they will come and feed themselves on this waste. Correct? The organic compost resulting from this process makes a nutrition-rich soil amendment that aids water retention, slows soil erosion, and improve crop yields. So as I said, there is two type of waste. The waste we are generating at home, and you can see. Did you see that? So you have two. If you have a house, you have two recycle bins. One is blue, said recyclable. One is just for normal waste coming from the kitchen. So you can see that's the recyclable. You can put all the aluminum cans, and even you can put the bottle, plastic bottle, because that can be recyclable too. And then the general waste will be dumped inside the landfill, and then at the end combusted through combustion by fire. You burn it. Reuse is even better than recycling. Even better than recycling or composting. Composting, you let the bacteria helping you take this job, okay, in the air. So some bacteria in the air will feed themselves on this waste, especially agricultural waste. But reusing is better than recycling. If you have the opportunity, not every time you can reuse the waste as is. You have to work on it to reuse it. So, but if you have the opportunity between or the comparing recycling or reusing will cost you less energy. From the profit point of view, recycling means you have to use technology which costs you money. Reusing just very, very minimum of using a new technology to deal with that. So that's about the cost. Reusing is better than recycling or composting. Is cleaning and reusing materials in their present form, thus saving cost and energy of remaking them into something else. Auto parts are regularly sold from junkyards. That's one example. What is reuse? Well, you can use the junkyard and use some parts from old totaled cars. They take all their good parts and sell it to the public. Stained glass windows, brass filling, there's other examples. Fine woodwork and bricks salvaged from old houses are all reused in construction. Some communities sort and reuse a variety of materials received in their dumps. Yes, they do that. You can see them in the Saturday or Sunday. I don't know, Saturday maybe. Some people will come through all the street of the community here, all the street, and they're collecting trash, and they sort the trash as they go. And they have special T-shirt, whatever they name their community what they are doing. It's volunteers, free of charge. They don't. Nobody's paying them in the community. They are doing it just. They are really environmental focus group people. So that's good. They come and as they go and then sort those waste. Like they find plastic, they find some bottles, some cans, aluminum cans. They sort them in different bags. Reducing waste is often the cheapest option. That's the best. To save yourself in recycling or reusing or combustion. Then is to reduce waste. This waste here. Recycling is good, but slowing the consumption of throwaway products is by far the most effective way to save energy, materials, and money. Industries are increasingly finding that reducing saves money. Soft drink makers are using less aluminum per can. See the aluminum. Old times, if you have soda 20, 30 years ago, you'll see the thick aluminums, and you can't see the cars nowadays. Most of the cars, if you have in the 70s or 80s driven a car, you can see how much steel. It's like a tank. Those old cars nowadays is like a tank, military tank. very thick steel. But nowadays, our cars are, most of the car in the whole world is a lot of plastics, correct? Even the bumpers, I remember in the 80s when I was driving, even the bumpers made of steel. Nowadays, everything plastic, correct? So that's, you can reduce the waste, and because the bumpers made of steel cost a lot of money when compared with the plastic one. So increasingly, industries are finding that reducing saves money. Soft drinks makers are using less aluminum. And now, I remember in the 80s, beginning 80s, it's very hard the aluminum to crush it to your hand. I mean, you will have to use a lot of your power to crush it. But now it's easy. With 2 fingers, you can crush the can, correct? Because the amount of aluminum is used is very, very thin. Fairly thin, thin aluminum they are used, not that much. That's the whole idea, is to reduce the waste coming into the environment. And that saves the companies a lot of money, rather than the old days. There is a very thick soda cans, very heavy, very thick aluminum. And soft drink makers using less aluminum per can, they did 20 years, correct? That's, I went up to almost 30 years ago. Excessive packaging of food and consumer product is one of our greatest sources of unnecessary waste. So now you'll see a lot of stores are using those degradable bags. And even I think the plastics nowadays they are using is biodegradable as well. Meaning as soon as you dump it in the ocean's salty tabor will come and destroy it, will be dissolving it. So it will not be as a bag there, plastic bag there. So excessive packaging of food and consumer products is one of the greatest source of unnecessary waste, where disposable packaging is necessary. We still can reduce the waste by using degradable materials. Somebody has seen the degradable bags? Some stores, they do have it. Some stores, they do have it. Degradable bags. When you take your groceries, you can ask if this is biodegradable. Means this, if I put it in tap water, it will be dissolved. Yeah. You can see even yourself. Looks like a bag, but it's a bag. It's holding the whole thing. But when you put tap water inside the sink, whole thing is dissolved. So that's biodegradable soap, which is good for the environment. Garbage, liability or resources. Well, it depends on how far the technology can go. It is a resource if we have the right technologies to manage this garbage or this waste. And liability, yes, it's another issue. If we have no good management, no good regulations and laws intact, then it's a big liability. You get a lot of people are affected by the lung cancers, all type of skin cancers, all type of cancer you can name it, because of this burning and all this combustion, all those gases, toxic gases will come out of it, or ashes or soot will come into the air. Municipal solid waste includes all our mixed refuse. Most of us don't spend much time thinking about where our waste ends up. But as you know from the principle of conservation, what's the principle of conservation? We said matter is not destroyed and not produced from nothing. Matter can go from one form to what? To another form, but it's never destroyed. If you have non-biodegradable, what they call it, non-biodegradable bags from the store for your grocery, and it end up in the ocean, this plastic bag will be there for millions of years to come, because it's not, the ocean tap water, the salty ocean tap water will not affect it. So it will stay there. It's not biodegradable. But if you have, on the other hand, the one made of biodegradable from cellulose, for example, correct? Like sugar. Cellulose is a combination of 300 or more sugar molecules. So if you have there, as soon as you put tap water inside, the whole thing will went to as glucose and sugar, and then will go and will be washed by the tap water inside the sink. And if you dump it in the ocean, it will be just dissolved in the tap water of the ocean. So, and as I said, matter is not created from nothing. Matter is always in cycle, in pool, transfer from one form to the other form, one form to the other form, in a cycle. So, elements in our waste such as aluminum, lead, carbon, or nitrogen don't disappear. There is no disappearing of matter, correct? They may sit in a landfill for centuries, millions of years, or they may be incinerated and emitted into atmosphere, or they may be recycled and transformed into another useful object. Here, just in this slide, let's just show you. This is that much of the left of the waste inside the that's much of the waste here in the landfill. So that's large of it is still there. But then when you do the combustion and burning, you get rid of this amount here. This amount here is, let's take this one here. So this amount here is recovered. That's the whole thing is landfill, the whole spot. But you can see, you can get rid of portion of the waste in the landfill by burning it. This is the portion here, and then you can recover by recycling. Let's take another one. This one here can be get out of the landfill by recycling. So the first, but the majority of the landfill is still there. It's not, see here, the majority is still there. This is the majority one is still there. And then the other one, let me have another color, violet here. This amount here is recovery from composting. Composting, what we said about composting, guys, the small tiny amount here in the top. Composting, we are using without our interference, we are using bacteria, correct? Bacteria to really feed themselves, enjoying feeding themselves on this waste. So out of this, that's the whole thing. You see here, that's the whole big landfill. I would say maybe less than 1/3 of it is gone by recycling, by composting, by using the bacteria, natural bacteria to work on it, and by combustion, burning it, or by the recycling. So you can see 1/3, almost 1/3 of the landfill waste is gone by bacteria feeding on this on the landfill, or you get the recycling, or you can burn the whole thing, burning the whole thing. So you can see recycling by far the greatest. The bacteria business is small, tiny amount, not that much. You can see. So if I just take this one to see it here, let me see this again. Here it is. The bacteria is acting this amount here. The bacteria. This one here about recycling, and this amount here is about the burning. So the recycling by far is the biggest waste removal from all the three. And the main landfill is still 2/3 still there at large. They're still at large. Okay, guys? Mm-hmm. What can you do reducing waste? Well, we can do as a person in a community, you can do a lot. Every one of us can do a lot. You can buy food that come with less packaging, or with the bags that are biodegradable. I think there's a lot of big manufacturing companies. They do have those bags. They call it biodegradable bags, mostly made of type of cellulose, means old wood or something like compressed wood or something, and then they are soluble in H2O. The problem with those bags, if you don't have an umbrella in the raining day, what will happen to your stuff? The whole bag will be dissolved. That's a problem. So whenever you are dealing with the biodegradable bags, take your umbrella with you, so you avoid any rain comes to the bag. So the non-biodegradable, the rain can come and wash all the bag from outside. Nothing will happen. But those biodegradable, the whole bag will be dissolved, because it's just cellulose made of 300 glucose in a chain. So they are highly soluble in H2O. So how we can manage this waste, to reduce this waste? Well, we'll take our washable, refillable beverages container to meeting or convenience store. Okay. Buy food that comes with less packaging. Then when you have the choice grocery stores among plastic or glass or metal containers for the same food, then buy the reusable or biodegradable one, or easy to recycle glass or metal, if that's the choice. If you have to buy any containers made of metal or glass, then choose the one that can be recyclable. Separate your cans, bottles, papers, and plastic for recycling. We have here, if you look at the whole campus here and downtown, all campuses, including downtown, you will see. I did not see the trash can, but it has trash and it has cans and it has plastics. So, yeah, we can reduce this waste by separating cans, bottles, papers, and plastic for recycling. Wash and reuse bottles. So all those here, as you can see, all those here ways to reduce waste. Wash and reuse bottles, aluminum foils, and plastic bags. Okay, so compost yard and garden waste, leaves and grass clippings. So that's most of those leaves are eaten by natural bacteria. So if you keep the leaves for 1 year, a couple months they will disappear. Why? Because this bacteria are feeding themselves on, and then you get all this cold weather and rain, that will take care of them. Help your school develop responsible system for disposing of electronics and other waste. Yes, that's happening. Yeah, that's really happening. That's done by the state with helping those universities. So, hazardous and toxic waste. And as I said, one of the worst scenario is the nuclear waste. That's the most difficult part of all the waste we know. We can't dump it inside the air, we can't dump it inside the ocean, we can't dump it. It has to be put in a special container, most of the time made of lead, to prevent any leakage of radiation, and keep it underground with the hope nothing will happen to this part of the land in the country. So, but if you have an earthquake in that area, that's the worst scenario. That's the worst scenario, because they can sieve those nuclear waste can sieve into the soil or through the soil to the table. The most dangerous aspect of waste stream is that often contains highly toxic and hazardous materials that are injurious to both human health and environmental quality. Hazardous waste includes many dangerous substances, and we'll tell you what those might be. Those substances what characteristics they have. Look at this. Those toxic or hazardous material or dangerous material, those are they are really lethal. So they are fatal, lethal to humans and animals at the small doses. Very small doses can cause death. Correct. Very lethal. Toxic, carcinogenic, mutagenic, all the stuff, all the above, causing cancer. I gave you one example, soot. Whenever you are burning your fire, don't stay near your fire. That's wrong. People are sitting very close to get warm. That's chemically not correct. Chemically is not correct. Stay away a little bit, get yourself a distance so the air will be sucked through the chimney and then to the air out. You are sitting very close to get yourself warm, but you are inhaling a lot of soot coming out of combustion, and then down the road you'll ask yourself, whoops, I have cancer in my lungs. From where? I've never been exposed to any chemicals. Well, you are sitting very close to your fireplace, and all the combustion reaction generating a lot of soot. And you see your chimney is dark black because of the combustion of unburned charcoal, of unburned carbon. So that's the soot. You will inhale it, you like it or not, if you are very close to that fire. So stay away from that, give yourself a distance so you don't inhale all this soot coming into your lungs. So ignitable with flash point less than 60, corrosive, explosive, all those characteristic, physical characteristic or physical properties of these dangerous substances we are dealing with. And they can come sometimes in the waste. You never know. They can come in the waste. So federal legislation regulates hazardous waste. Two important federal laws regulates this managing this hazardous waste. One here, two here. The Resource Conservation and Recovery Act, pronounced RCRA, of 1976, and the Comprehensive Environmental Response, Compensation and Liability Act, CERCLA, or just they call it Superfund Act. Amendments and Reauthorization Act, SARA, is aimed at rapid contamination and cleanup or remediation of abandoned toxic waste sites. And that's the reason when old mines are used and nobody is using them, the law will tell you to shut them down. Nobody can re-enter, because if you re-enter old mining copper mines there, that's old. No more copper inside. But if you are entering, there's a lot of other contamination inside. Those are another source of contamination. Nobody should enter there, so they lock the whole entrance to this mine, to the abandoned mines. Superfund sites are those listed for federal cleanup. The Superfund is a revolving pool designated to provide an immediate response to emergency situations that pose imminent hazards, and to clean up or remediate abandoned or inactive sites, such as mines. Mines is another source of abandoned waste. There are maybe over 400,000, close to 500,000 Superfund sites in the U.S. Total cost of hazardous waste cleanup in the U.S. are estimated between $370 billion to $1.7 to close to $2 trillion. Brownfields presents both liability and opportunity. In many cities, there are large areas of contaminated properties known as brownfields that have been abandoned or are not being used to their potential because of the real or suspected pollution. Yeah, you can see a lot of brownfields in some cities there. Not direct in the center of the cities, but those are always at the backyard of the cities, outside, couple 100 miles from the cities. But they are close. They are close to the cities. Up to 1/3 of all commercial and industrial sites in the urban core of many big cities fall in this category. As I said, those are not inside the city per se. Those are inside, far off the cities. It is hard to find buyers for such property. Nobody will buy. The buyers will tell, well, I did not create this mess. Why should I spend first money to clean up, and then I have to spend money to have my own business on it? So that's a no-no. So therefore they are abandoned. Nobody wants to buy them. And the cities, they have not that much resources to clean up those brownfields or those sites. So it's hard to find buyers for such properties, as who would be interested in redeveloping brownfields, knowing that they might be forced to pay millions of dollars to clean up pollution they did not create. As I said, that's not my mess. It's somebody else's mess. So it's end up then the cities, they don't have the fund. It ends up then the federal government will intervene and help. If that's it, those sites are in bad, very imminent, very bad situation, then the federal government will come and help. Because I don't think so the cities will have the resources for this. It costs millions of dollars to clean up. Hazardous waste must be processed or stored permanently. As I said, storing is an issue. It's not by the source, but that's an issue with the nuclear waste. That's an issue with the nuclear waste, because if you have an earthquake and those special container crack, that's a big issue. To clean up the tap or reservoir takes a lot of time and money. It costs a lot of money and time to clean up tap or layers inside the soil. By only what we need the job. So what this hazardous waste must be processed or stored permanently. And what shall we do with toxic and hazardous waste? In our homes, we can reduce waste generation and choose less toxic materials. Buy only what you need for the job at hand. Use up at least a little bit or share leftover with a friend or neighbors. Many common materials that you probably already have make excellent alternative to commercial products. So you can store this. As a matter of fact, I have an old painting cans. I just called the DeKalb County asking them, I have leftover a little bit of, can I just dump it here and anywhere? They said, no, bring some clay on it, soil, mix it with the soil, and then you can put it in up front, they will take it. They insisted on the soil because they don't want to have this leftover small tiny amount of paint will leak out for some reasons. But it's already soil's absorbing it, and in a very hard will absorb. So there is no liquid of this paint will go through the landfill. So, and that's we have to really. If you have an old painting can, it has a little bit of paint, mix it with soil, so you can be decreasing amount of waste, hazardous waste into the environment. Produce less waste. As with other waste, the safest and least expensive way to avoid hazardous waste problem is to avoid creating the waste in the first place. That's really true. If we can reduce or eliminate or avoid this waste to begin with, that would be the best way. Manufacturing processes can be modified to reduce or eliminate waste production. It is frequently found that these new processes are not only sparing the environment, but also saving money by using less energy and fewer raw materials. Convert to less hazardous substance. Several processes are available to make hazardous material less toxic. Physical treatments or tie-up isolate substances. Combustion is applicable to a mixture of waste. A permanent solution to many problems. It's a quick and relative easy, but it has always this idea of polluting the air with the toxic material. Chemical processing, that's a good one. This is really used. You can use chemistry to help you with those toxic material by converting them to harmless or less toxic material. Chemical processing can transform materials to make them non-toxic. Included in this category are neutralization, removal of metals or halogens, chlorine, bromine, etc., and oxidation. Store permanently. Well, as I said, you have two types of storing permanently. Permanent retrievable storage involves placing waste storage container in a secure place. That's the nuclear waste. The nuclear waste in a container, because something happened or you predict there will be earthquake in that area, you can go in quickly and take those containers out and keep them in a safe side until the earthquake alerting zone is done, and then you can bring them back to their original place. So permanent retrievable storage involves placing waste storage in containers, that's especially chemicals and nuclear, especially the nuclear, especially chemical, highly toxic chemicals and nuclear waste. You put them in the containers in a secured place such as a salt mine or bedrock cavern, or where they can be inspected periodically and retrieved if necessary. And that's what happened in the nuclear waste. But if there is a sudden earthquake, then we are out of luck. We are out of luck. Secure landfill are the most popular solution for hazardous waste disposal. Newer techniques make it possible to create safe, secure, modern landfill that can contain many hazardous waste. What we can take away from this, that's a summary of the chapter. Well, modern society, however, produces a huge amount of waste. The regulation and rules done by the government, local government, and the federal government can really regulate and control the outcome of this solid waste, correct? And they can make they can encourage a lot of technologies to deal and manage this waste, and they can scale this waste to cheaper and more convenient to extract original or virgin raw materials rather than to reuse or recycle those wastes. The rising cost and declining availability of landfill have led to new and creative strategies to reduce, reuse, or recycle waste. Paying attention to recycling, reusing, and reducing household and hazardous waste can greatly improve our awareness of environmental liability. That's what chapter 14 is done. I will go for chapter 3. Let me see.